Yes. So let us continue. Fifth one, I think. Yesterday I have given 5 problems only. So let's look at this. F of x is equal to sine inverse of fractional part of integer part of 3x plus 2 minus again fractional part of 3x plus x minus again fractional part of 2x for all x belongs to 0 comma pi by 12 and G circle f of x is equal to x means G and f are inverse to each other. Similar model we have done, but we have to simplify this. Make this function free from integer part and fractional part within the interval. Then what to find there? G dash derivative of the function g at pi by 6. Options also given. Solution 0 less than what is given there? 0 less than x less than pi by 12. Correct? Okay. Multiply with 2x less than pi by 6. So 3.14 by 6. Pi means here 3.14 by 6. Anyway, it is less than 1 only. Correct or not? So what is the fractional part of 2x? Fractional part of 2x is equal to actually 2x minus integer part of 2x. Already we know it. Definition of the fractional part. So 2x minus 0 because the integer part of 2x will be 0 because it is 0 to 1, 0 point something. Pi means 3.14. 3.14 by 6 is again 0 point something. Some 0.5 will get. So finally I am getting fractional part of 2x is equal to 2x. So in this part I can write only 2x. Correct or not? So function f of x is equal to, tell me, sine inverse of fractional part of integer part of 3x plus 2. Because 2 is integer, I can write out of that box minus fractional part of 3x, x minus 2x it is. X minus 2x means minus x. Again fractional part of x, correct? And also one more fractional part of x. So again we are getting here 3x minus x. 3x minus x means 2x only. Fractional part of 2x is again 2x. Look at this. So also whenever 0 less than x less than pi by 12 multiply by 3. Multiply by 3 because we need to find this value of this box. So if you multiply by 3 we will get 0 less than 3x less than pi by 4. Again it is 0 point something, 0.7. So integer part of 3x is 0. So we are getting here 0 plus 2 minus 2x. This part is again fractional part of 2x. Fractional part of 2x is 2x. So function is sine inverse of fractional part of 2 minus 2x. Understood? Again you have to simplify this or make this free from fractional part. Now 2 minus 2x. Fractional part of 2 minus 2x is, how to write it? 2 minus 2x. 2 minus, I mean some alpha minus box of alpha. 2 minus 2x. You can write 2 outside, minus 2 minus integer part of minus 2x. So 2 to cancel. What is the box of minus 2x? Whenever 2x lies between 0 point something, 0 to 0.5, it would be minus 0.5 or minus 0.4 it is. Minus 0.4 means box is 1. I mean actually minus 1. Outside is minus, so finally I am getting 1 minus 2x. Therefore function is sine inverse of 1 minus 2x. So entire function, this function is nothing but sine inverse of 1 minus 2x. Understood? Now there is no problem to find derivative, but we have to find derivative of the inverse, right? F of x is equal to sine inverse of 1 minus 2x. What is given here? G circle f of x is equal to x from this g dash f of x. If we differentiate, we are getting like this. In the previous class also we have done this chain rule. Now we have to find g dash of pi by 6. So when it is pi by 6 means whenever x is 1 by 4, then what do you get there? 1 minus 2 by 4, 1 minus 1 by 2. So therefore whenever x is equal to 1 by 4, so put x is equal to 1 by 4, I am getting g dash of f of 1 by 4 is equal to 1 by f dash 1 by 4. So now one what you can do, f of 1 by 4 is nothing but, tell me, just substitute 1 by 4, you are getting required one only, g dash of pi by 6. Then differentiate this function and apply 1 by 4, you will be getting the required answer, that is fourth option. You can do it. So it is only main point first. Now onwards you can do. So finally you are getting g dash of pi by 6 is equal to minus root 3 by 4. What to do last? You differentiate this function and substitute x is equal to 1 by 4. So option D is correct. Understood? So next one, f of x is equal to 1 minus x by 1 plus x whole to the power of 1 by x whenever modulus of x less than 1 and x not equal to 0. Whenever x is 0, then e to the power of 1 by 2 is the functional value. Then we have to find left hand derivative and right hand derivative at 0. Exist or not, or what is the relation between p and q, right? So f dash 0 plus, suppose, by first principles, f of x minus f of 0 by x minus 0, limit x tends to 0 plus f of x means 1 minus x by 1 plus x whole to the power of 1 by x minus 1 by e square, e power 1 by 2 by x. So let me check once, 1 by e square or e power 1 by 2, because you have to get compulsory 0 by 0. So it is 1 by e square, it is 1 by e square. Okay. Here also 1 by e square or e power minus 2. Okay. Right. So limit x tends to 0 plus f of x minus f of 0 by x. Now you have to find the limit value. This limit value. So limit x tends to 0 plus, then how to write it? E power, you can write like this, e power ln 1 minus x by 1 plus x power 1 by x minus 1 by e square whole by x. Because e power ln theta is theta itself, correct or not? Now we can write like this. Next step, limit x tends to 0 plus 1 by x. You can take this 1 by x to the in front of the logarithm, right? E power 1 by x ln a by b. Ln a by b means ln a minus ln b minus 1 by e square whole by x, right? Now I can use the expansions of ln of 1 minus x and ln of 1 plus x and subtract that. So ln of 1 plus x is x minus x square by 2 plus x cube by 3 minus x power 4 by 4 plus so on up to infinity for x mod x less than 1 or 1 plus x is positive. Again ln of 1 minus x, tell me, replace x by minus x. It is a logarithmic expansion. In this place of x, write minus x. You will be getting minus x square by 2 minus x cube by 3. Because even power is there, therefore there is no change. For odd power I am getting minus. Subtract now. So ln of 1 minus x minus ln of 1 plus x. You subtract, what do you get? Minus x minus x. Look at this. Minus 2x. Again it will be cancelled. Minus 2x cube by 3 minus 2x power 4 5 by 5 minus so on. Divide by x, because we are having this one. Look at this. Dividing by x, then ln of 1 minus x minus ln of 1 plus x by x is equal to, tell me, minus 2 minus 2 by 3 x square minus 2 by 5 x power 4 minus so on. Understood? So in this place I can write that part. So f dash 0 plus is equal to limit x tends to 0 plus e power minus 2 by 3 x square minus 2 by 5 x power 4 so on minus e power minus 2. This one 1 by e square is nothing but e power minus 2 whole by x. Now 0 by 0, apply LH rule. Because if you apply 0 here, it becomes 0 only. E power minus 2 minus e power minus 2. So 0 by 0 we are getting. Apply LH rule only one time, then you will be getting right hand derivative. So LH rule or L'Hopital rule, f dash 0 plus is equal to limit x tends to 0 plus derivative of e power something, e power minus 2, same, minus 2, what is that, minus 2 by 3 x square, okay, e power something derivative, e power something only, again this something derivative is this one, minus 2 derivative is 0, again minus 2 by 3 x square is, derivative is minus 2 by 3 into 2x like this. If you apply there 0, you are getting, this part is 0, e power minus 2 into 0. So small p is 0. So derivative is 0. That is right hand derivative. Similarly you do left hand derivative also will be 0. The final answer is differentiable p equal to q equal to 0. You do right left hand derivative. I have done here RHD, similar same model. Because there is no change here. Understood? Next one, let f and g be twice differentiable functions on R, and f double dash 5 is equal to 8, g double dash 5 is equal to 2, then find this limit. So easy, comparing with previous problems, easily can do. Apply derivative 2 times, I mean LH rule. We are getting 0 by 0 form. So L is equal to, tell me, limit x tends to 5, LH rule, f dash x, f of 5 derivative is 0, x minus 5 derivative is 1 only, so we are getting f dash 5 constant, that is denominator also we are getting g of g dash x minus g dash 5, again 0 by 0, again apply LH rule. So let me complete here. Limit x tends to 0, f double dash x, derivative of f dash g double dash x, apply limit 5 it is. We are getting f double dash 5 by g double dash 5. So what is that? 8 by 2, 4. Answer is 4 because already given these two values. 39th. So next one, f of x is a differentiable function where f of x is equal to e power x plus 2x is given. Then find the derivative of the f inverse x at x is equal to f of ln 3. So today also I have done. What is the point there? G circle f of x, where g is equal to f inverse is equal to x. G is equal to f inverse. It is the theorem we had. If you operate f and f inverse within the domain, then we are getting identity function. X is called identity mapping. So if we differentiate it, g dash f x is equal to 1 by f dash x, because by chain rule. Okay, in the place of x you have to put ln 3. So g dash of x means, look at this, f ln 3 na, because f inverse x. 1 minute. X is ln 3. G is the inverse, that is f inverse. Derivative of the function f inverse at f ln 3 means x is equal to ln 3. So 1 by f dash ln 3. Ln 3 means logarithm to the base, you know it. So from this tell me, you should differentiate separately f dash x is equal to e power x plus 2. Substitute ln 3 or ln 3, f dash ln 3 is e power ln 3 is 3 plus 2, 5. So we are getting 1 by 5. Is it right? Next 40th one. Sorry. So once again have a look. T of, once again, another beautiful problem is there. T of x is equal to x square minus 1, x cube plus 1 into sin of x plus 1, x plus 1 into e power x plus 1 minus 1. Second row is 2 power x minus 1 by 2, 0, x plus 1 whole square, root of x square plus x plus 1. Third row, 0, x to the power of 6 minus 1, 0. We have to find third order derivative at minus 1. So once think about this, without expanding we have to solve it. Otherwise very lengthy. But by using our properties of determinant we can do easily. Suppose I put x equal to -1 in first row, it is 0. 0. -1 plus 1, 0. It is 0, this part. So first row completely zeros on putting x equal to -1. Put x equal to -1 in second row also, 2 power -1. We are getting 1 by 2. 1 by 2 minus 1 by 2, 0. 0. Again it is 0. But it is double root. Square is there now. Therefore x equal to -1, of course anyway 0 only. Third row also 0. On putting x equal to -1. Again look at this third column. This is also 0. If you put x equal to -1, e power -1, because e power 0 I am getting, 1 minus 1, 0. Again it is square, that's what I told. Second row I am counting 1x plus 1. Third row, third column means 1 more x plus 1 I will count. So finally, one minute. If we put x is equal to -1, then first row, comma second row, comma third row, comma third column are completely zeros. Therefore, x plus 1 is a factor but repeated 4 times. So x plus 1 whole power 4 is a factor of d of x. So if you expand this det, you will be getting x plus 1 power 4 into something. Understood or not? It is also property. So for example, already we have discussed that xxx some a or axa. 1 minute. xaa, axa, aaa. Suppose if you put x equal to a, two rows are equal. Put x equal to a, two rows are same, then that is 0. So x minus a is the factor. Actually it is quadratic. 1x, 1x. So in quadratic we are having two roots. But without expanding only you can say root or factor. Same logic here also. X is equal to -1 will make first row, second row, third column zeros. So x plus 1 will repeat how many times? 4 times. Therefore t of x is equal to x plus 1 power 4 into some g of x. Okay, no? Compulsory in this answer, in the expansion of this det, x plus 1 power 4 will be there and also something gx, some other function. Now apply 3 times derivative. Just UV rule, apply 3 times derivative 1 by 1. Put x equal to -1, we will be getting 0. 0 is the answer. Okay, if you do 4 times, that would be constant, some other constant. Right or not? For example, x cube is there. Do differentiation 1 time 2x. Once again do it. 3x square, 6x, 6. So it is first derivative, second derivative, third derivative. Degree 3, if you do 3 times, I am getting constant. If you do 2 times, x will be there. Correct or not? Same logic. Degree 4 here, only up to 3 times only I am doing differentiation. So definitely x is equal to -1 will make 0. So that is the answer. Okay? It is the approach. f of x equal to, okay, f of x is equal to ax cube plus bx square plus ax plus 5 if modulus of fx is less than or equal to mod of e power x minus e square for all x more than or equal to 0, and if the maximum value of modulus of 12a plus 4b plus c is L, then find the integer part of. So what is given there? Modulus of fx is less than or equal to modulus of e power x minus e square. Put x is equal to 2. Okay, x is equal to 2. F of 2 is less than or equal to 0, because e square it is, e square minus e square is 0. Mod f2 is less than or equal to 0, but mod cannot be negative, only possibility is f of 2 is 0. You write the point. Modulus cannot be negative, only way is 0, equal to 0. Now again, once again from this also, so from this condition f2 anyway 0, look at this, f of x minus f2 by x minus 2. So dividing by modulus of x minus 2 on both sides for the given inequality, this one, to get the first principles. So apply limit x tends to 2. So automatically it is the first principles. So it becomes f dash 2 only is less than or equal to, and what do you get there? Limit x tends to 2 e power x minus e square by x minus 2. So 0 by 0 form you are getting. Okay, apply LH rule, L'Hopital rule, then what do you get? E square, e power x only, remaining zeros by 1. So apply 2 there, e square itself. So modulus of f dash 2 is less than or equal to e square. Okay, understood? F dash 2 means, look at this derivative. What is this? 3ax square bx square 2bx plus c. In that x 2 substitute 2. So automatically you will be getting 12a, required one only, 4b plus c is less than or equal to e square or mod e square, no problem. You can remove modulus. E square is positive. Understood or not? What to do here? Differentiate this and put x equal to 2. This only L, maximum value, less than or equal to means maximum value. So maximum value is e square. So L is e square. E square means 7 point something. E is 2.718. Therefore box of L is nothing but 7, because it is 7 point something. Answer is 7. Okay. So in the next class we can do remaining problems up to 42. You complete it tomorrow. Okay. Bye.